You've joined today. This is the webinar we're putting on is what weather inspections to find inflow and infiltration, or INI. Just a few housekeeping items. So this is kind of typical for our webinars. It's usually two parts, sort of a presentation and then a Q&A or discussion session at the end. You'll find at the bottom or in Zoom, you can type in questions in the Q&A window. During the presentation or after the presentation, and we can chat at the end or try to address all the questions or any questions that come up. If you do have a question and you do want at the end to put your hand up and come off mute and ask the question sort of not through typing it, then we can do that as well. So just again, if you do have any questions along the way, feel free to throw your hand up and we can get to you at the end. We'll try and get through all the material first and then do that sort of Q&A discussion piece. And then, typical for our webinars, we do have some polls throughout, so keep an eye out for the polls. I think we have 4 or 5 this webinar, so just keep an eye out for the polls and feel free to answer them as they pop up. So the presentation today, so we'll do a bit of an intro to us and a background on a little bit about INI. We won't get into it too much. We'll talk about sort of, our methodology or the things that we can do to find INI. We'll dig into wet weather inspections, define what that means. Maybe it seems straightforward, but we've been doing this for a few years, so we have our sort of thoughts and opinions on what that means to do wet weather inspections. We'll talk about some results from a few case studies or a few examples anyways of INI that we've been able to find and talk a little bit about some of the details of a few projects that we've worked on where wet weather inspections were very helpful in the work that we were doing. Talk about a little bit of our future direction, some of the other techniques that we are currently employing or hoping to employ over the next little while, some conclusions and recommendations, and then, as I mentioned, the sort of Q&A and discussion portion at the end. So I think most people on this call are fairly well aware of Civica. So for those that are not, we're a company that's focused on capacity. A lot of our work is in collection systems, storm systems, sanitary systems, combined systems. And really our mission, as part of INI reduction or INI management, but even as a broader sort of mission for our company, is to help kind of build resilient communities during these periods of rapid growth, a lot of population growth and development growth, and changing climate through maximizing the use of the existing infrastructure that we have in the ground. And that's been really our guiding sort of principle for the last 10 years that Civica has been around. I'll quickly introduce myself. For those that don't know me, Matt Malone. I'm a project manager, but also the vice president of business development at Civica. So I've been doing work in this sort of area, INI, capacity management, field work to support a lot of that work for the last 8 or so years, both in the consulting and on the municipal side. So try to put myself in the shoes of a lot of the municipalities that have done the work and experience these types of challenges day to day. And then I'll pass it over to Alex to do a quick intro as well.
Hi everyone, I'm Alex Dean. I'm a project manager and also I'm the operations manager at Civica. So I look after our project delivery and day-to-day operations for field work for looking for INIs, and we also do a lot of flow monitoring and modeling work for capacity management analysis and master planning studies for municipalities. So I'm very happy to be here today to share some of our experience that we gained from the past.
Awesome. So as we've done in previous webinars, we've told us a little bit about ourselves, or told you a little bit about ourselves. So we'd like to, launch the first poll and kind of get an understanding of where you guys are coming from. what type of organization you work for. So you should see a poll pop up somewhere on your screen, and you can, hopefully it should be a pretty easy click to send in your vote or your results. Right. So just give a couple more seconds. Okay, so we're over 80% participation. That's pretty good. So right now we have 34 people on the call, majority of which are working for municipalities. Not surprising. I think this one's probably a little more targeted to the municipal sector, a few engineering consulting, and a couple from other. All right, so that's great. Now we know a little bit about who's here and what the audience is looking for. So, I won't really go into too much detail on, what is I&I. I think probably most people in this room have a good sort of idea of what that is. So why, but why I&I is a problem? Why is this groundwater and stormwater getting into wastewater systems such a problem? So typically we categorize it into a few different areas of why this is a problem and why we may want to reduce or manage this, I&I in general. So, I live in Toronto. There's been a lot of studies, a lot of money spent in the last 10, 20 years on the basement flooding protection program. And so trying to reduce basement flooding and sewer backups as much as possible is certainly a driver for a lot of the work that we do. Environmental protection, trying to reduce or eliminate things like combined sewer overflows, sanitary sewer overflows, bypassing a treatment plant. There's certainly regulatory compliance, and with the new ministry's CLI ECA regulations and the guidance around I&I allowances, certainly I think a lot of municipalities are keeping that in mind when they're looking at their targets and trying to hit levels of I&I that are sort of more in line with design criteria. The infrastructure upgrades, when we're looking at accommodating flows, wet weather flow or I&I, you may be upgrading your pipes or pumping stations or treatment plants, and those are certainly costly infrastructure upgrades that, if we can reduce some I&I, then maybe there's opportunity to not have to upgrade some of these larger pieces of infrastructure to quite the extent. And then also growth needs in the GTA, Southern Ontario, and certainly out west. I know there's some people, some folks from the West Coast. When we talk about new development and accommodating flows for to grow and to grow sustainably, it's certainly something that we do a lot of work in Ontario to try to reduce I&I to allow this growth to move forward. And with that, I'll pass it over to Alex to take us through the next few slides.
Thanks, Matt. So the preferred solution for dealing with I&I is always to remove those I&I sources whenever possible. When it comes to finding I&I sources, these are the typical investigation methods that we use on the field. Flow monitoring is always recommended to be done ahead of other field inspection to understand the severity of the I&I problem in the catchment area, and also to isolate and prioritize field inspection effort based on the I&I response. And like I said, the severity of the I&I, you may have different baseline I&I in different catchment areas, so you want to kind of focus your effort, your field inspection effort towards those high response areas, as opposed to these areas that are not showing a lot of I&I. So moving on to the field inspection side, usually lot inventory inspection is done ahead of other inspections. It is essentially surveying and recording all the visible drainage features on the public side as well as on the private side, and putting the data into a database. It's usually GIS-based database, so you can use this data later on for your field inspection and recording purposes. Once the drainage features are all identified for and and dye testing are effective techniques to identify potential cross connections between the storm drainage features and sanitary. And usually we would do fault testing to kind of find those potential connections, and do dye testing to confirm the hydraulic connection. Because sometimes smoke comes out, it doesn't mean it is necessarily hydraulically connected. So we would always do dye testing to confirm there's a hydraulic connection between those drainage features. On a public site, video inspections of manholes and sewer pipes can reveal certain infiltration defects. And also, last but not least, this is what we're talking about or focusing on today. Inspection of those infrastructure during wet weather conditions is also very effective, and it will reveal a lot of the sources that are not active during dry weather conditions. So these are some pictures showing some examples of the fielding investigation I just talked about, and those are the typical inspections we do on the field. The inspection mentioned in the previous slides are usually done in sequence, starting with the more conventional inspection, including flow monitoring, fault testing, dusting, and moving on to more challenging inspections such as wet weather work. And for some more complex sites or site-specific conditions, there is going to be some very specialty techniques that needs to be applied, and it's case by case and site specific. So we have to kind of tackle them one by one. But in general, you would go from the more typical conventional method and moving on to more challenging, but it's more rewarding wet weather inspection. And if there's some very special cases or very like I said, complex cases that requires more engineering analysis and requires some detailed planning and a strategy to find those INI. Okay, when we talk about wet weather inspection, let's first define what is considered to be wet weather. There's often a misconception that wet weather only refers to when it's raining. While it's certainly true, when it's raining, it's wet weather, but wet weather kind of goes beyond when it's just raining. For example, in spring seasons, when there's rainfall plus snow melt, and when the groundwater table is high and the antecedent moisture condition is high, this is also this should also be considered to be wet weather conditions, because the ground is saturated, and you will often see more active INI defects in spring. And also for rainfall or shortly after rainfall, there's certain time window that is also good for doing wet weather inspection, and each catchment area is different depending on the nature or the characters of the catchment area. And this is when flow monitoring comes really handy to help you to understand the recession time, how long of a window of opportunity you have after a rainfall event, that just to extend your opportunity to find this INI, or extend your time that you would have to find this INI during wet weather. And why wet weather inspection is important, it's a good idea. Well, this is when INI happens, or more specifically RDI, rainfall derived INI happens, and this is when the system capacity is most at risk, when there's too much storm water or rainfall water going to the sanitary system. And this is you particularly interested in when this type of situation happens. Is your capacity still sufficient, or there is something that is affecting your capacity because of these INI defects. Next, I would like to show two examples from our flow monitoring data. This slide shows a flow monitoring result from the catchment area in Lindsay. The blue bar here represents the monthly cumulative volume from January to April. As you can see, the flow value or the volume almost doubled in March in comparison to January. And this is because of the snow melt and groundwater infiltration going to the sanitary sewer. In this case, we actually did a lot of successful wet weather inspection operations in the month of March, and we were able to find quite a lot, infiltration defects in the manhole and sewers. And this kind of agrees with the data, what is showing here, because you seem to have more water in March in a sanitary system. Here's another example. I believe this is a catchment area in Newmarket. So this hydrograph shows elevated base flow in spring season. If you take a look at the hydrograph towards the left-hand side, there's normal base flow, which is the minimum flow, and that's from February this year. So it was just around 1 to 2 liters per second during February period, and after a few rainfall events, all of a sudden it went up to 15 to 16 liters per second, and that's the elevated base flow as a result of the rainfall and snow melt and the ground condition, AMC, etc. And there's a few week window of opportunity there for you to do wet weather inspection, because there's just more flow present in the sewer. That's a result of all kinds of defects contributing to this flow. Next slide. Okay, here is another poll. We would like to ask this question: do you notice significant seasonal variation in your sanitary flow in the jurisdiction you work in? It could be from your flow month data, or if you're working in operations, it could be feedbacks from the operations staff. Like they may notice there's more flow just by popping up the manhole lid and see, yeah, in springtime, there's more flow, or versus summertime, it seems to be a little bit dry, or whenever it's raining in some places, there's elevated flow present in the sewer. So we just like to kind of understand whether you notice this is a problem in your system or not.
Awesome. So still getting a few more answers in. I think we have I'll share the results. So there's nobody that's saying no. So it seems like it is a common problem. So it's either between yes, or in some areas yes, others no, which is common, I think, in a lot of jurisdictions, a lot of municipalities, that it's either a system-wide sort of phenomena, or there may be certain catchments or certain areas of the system that experiences more than others. So very interesting results there. Okay.
Okay, next, let's use this example. This is typically what we can see from the CCTV inspection, or like inspection of the main line, the sewer pipe. What's the difference between a dry weather and wet weather inspection? During for this sewer cracks during dry conditions, if the groundwater table is low or the antecedent moisture condition is low, these cracks, even though they exist, they're not under pressure. So you may not see, or you will not see water going into the pipe through these cracks. However, when it's wet, during rainfall, or during a snow melt or spring season, the groundwater table is high, and the antecedent moisture condition is high. There's usually water outside of this pipe, and this hydrostatic pressure starts to push the water into the pipe, and this is when you notice these defects become active. And this is when, or this is the best time for doing such inspection, because these defects are active, and if you do the inspection during those conditions, you will be able to catch them, compared to if you were to do it under dry conditions, even though they exist, they're just not active. And here are some examples of the wet weather defects that we found in the past. If I remember correctly, all these 3 defects were found last year in Newmarket, in our I&I project in Newmarket. Believe it or not, all these places we inspected them during dry weather, and nothing showed up. We couldn't find all these INIs, and we, starting from last year, we switched our focus from doing just spread out dry weather inspection to more focused wet weather inspection. The priority is determined through long-term flow monitoring data, and we were able to pinpoint to some catchment areas. We kind of direct our field team to go and visit those manholes and sewers that were already visited during dry conditions, and we were able to find quite a lot defects during one or two major storms, major summer storms happened last year. I believe all these three were found in a storm in August. It wasn't a particularly big storm, but the beauty of that period was, there were another two storms happened just a few days ahead. So the ground was kind of wet, and the antecedent moisture condition was relatively high, and these defects, they were revealed, and you can see on all kinds of gushers. These are mostly at the interface where the pipe kind of breaks into the manhole, and there were a lot of defects like this. These three were just some more significant defects as an example. With that, I'm gonna pass it over back to Matt.
All right, thanks, Alex. And yeah, kind of piggybacking on what Alex was saying there, and you were talking a little more theoretical at a point there with the pipe and the groundwater. There has to be these defects and the groundwater interaction, and that's sort of a conceptual model of what happens during wet weather. But then looking at some of the results, that last slide showing sort of pipes and manholes where we had investigated and gone there during dry weather and hadn't seen anything, and then gone back during wet weather, and it's a totally different story. So I'm gonna present a few sort of case studies, examples, if you will, that show a little kind of a similar situation, at least for the first case study or example here, and then talk a little bit about some of the other work that we've done, specifically in wet weather, to help further along a couple of the projects that we worked on where dry weather inspections weren't really telling the whole story in a sense. So so this first one, this is again in York region. So this was a site, and the picture on the left says dry. I mean, it was still during or shortly after a rain event. So but certainly drier than the picture on the right. So we had gone to this particular location during a smaller storm, and noticed that this was a little creek in the area, had sort of elevated flows, but that sanitary maintenance hole located there was still not quite in the influence of that creek. The picture on the right, we went back during a larger storm event, still less than a 2-year storm, and the creek had overflown the sort of banks in a sense, or just had swelled because of all the rain. And now where that sort of little red dash circle is, that's the location of that maintenance hole, and that's underwater. So depending on the location, there are a lot of municipalities that are putting in sort of fully bolted down covers and frames, and maybe it would still be good under this situation. There's probably a good idea to raise that up a bit regardless, because you don't want that interaction. But just one example, and another one that we have here, same situation really. So the picture on the right is what we'll call a dry situation, and we actually went to this location. The picture on the left, I think it was early June, so there was still some water in this drainage channel beside this particular manhole. And we had actually been at this location. We had CCTV'd the pipes under this particular easement. I think it was in August or September of the year before, and that drainage channel was completely dry. It was just full of vegetation, no standing water. But you go back and you target these things. You look at potential for them to become inundated and flooded during some of these events. So we went back, and the picture on the right is from again a larger storm, still less than a 2-year storm. And this is what we saw was this, elevated water table, definitely interacting with this piece of infrastructure. So when, you can see the lid is off, and when we pop the lid, this is what we saw within that particular structure. So, a fair portion of that drainage channel and the water in that drainage channel was getting into the system through this particular location. So, this is just one example, but certainly something that we've seen in multiple locations. Even if this location did have a fully sealed bolt down frame and cover, it doesn't matter in this particular location because it was getting through that sort of chimney interface between the cone and the sort of precast structure and anything that was on top. So just an example of some of the inspections and some of the prioritization and going back to some of these sites that may be sort of prone to being flooded during some of the wet weather events. The second case study I'll talk about, this started, as you can see, back almost 7 years ago now. This was a study, and I call it case study 2A because I'm going to show you kind of case study 2B, which followed up from this original one. So this was a storm, 53 millimeters over 17 hours. It's a significant storm, but not really anything out of the realm of what's possible. It's still less than a 2-year storm. So this was a study that we did in the city of Toronto, and there's a video online, and I'll reference that at the end. But anyway, so you can see this is just a hydrograph from one of the downstream flow meters, I believe, at the outlet of the study area. So you can see that response, maybe 1 to 2 liters per second during dry weather, and then another, multiplying by 6 or 7 times during this wet weather event. So quite a large response, quite a high INI rate for this study area. And so the objective, we had gone through this process of performing investigations, doing things like smoke testing and dye testing. And we had found certain sources that we just didn't know what was going on. Maybe it had a little bit of wispy smoke, or we couldn't identify through sort of dry weather dye testing the ultimate outlet for some of these locations. So our thought was, okay, let's go back during wet weather and test these sources again to, finally nail down ultimately where they're draining to. So this led to a few different things. So first, we were able to go to a number of different properties, a number of different addresses, and actually confirm majority of these locations as to where they ultimately connected to, whether that was the storm or sanitary sewers. So the first 5 on the list here, we ultimately were able to confirm at that point that yes, they were connected to the sanitary sewer system. There were a couple catch basins that were in the back of lots that when we did traditional dye testing, for whatever reason, lots of storage in that pipe, probably, or maybe some sort of exfiltration, some defects within the pipe connecting it to the storm sewer, that it wasn't actually showing up in that downstream storm sewer when we were doing it during dry weather. So again, just some peace of mind when we were doing this project as to where ultimately a bunch of these potential sources connected to, whether that was sanitary storm or the surface at a point downstream. And then as part of doing this work, as part of the dye testing work that we were doing, we were also performing CCTV inspections sort of concurrently or at the same time. And what we had identified in the pipes that we had inspected was that, we have a lot of these laterals which were producing a lot of flow into the system, during the storm event and then after as well. So out of the 26 laterals that were inspected, or at least sort of passed by in terms of when they were doing the mainline inspection, only 4 had low or no flow. And then we had 20 with moderate, what we call moderate flow, and then another 2 with high flow. And so it got us to thinking, okay, this is a pretty significant source of when you look at the videos, it's clear water. It looks like kind of storm water. So we're thinking these are probably fairly significant sources of I&I. And now our next question, which led to sort of the second half of this case study, was, okay, is this water, is this I&I getting into the system? Is that from defects within the laterals themselves, or is it coming ultimately from the foundation drains? So then we did this follow-up case study, or this follow-up, little project. And this is a much smaller rain event, only 16 millimeters of rain. And that's one of the challenges that Alex will talk about later is, how do we get out there? How do we mobilize, and how do we be there for some of these events? Or maybe you'll wait 6 months without getting rain. It just depends, right? So, but this is what we had. This is what, ultimately we were trying to get something that was at least 10 to 15 millimeters so we could go out and do a follow-up study. And so really the objective for this study was sort of validate the connectivity, or validate the location of where some of the I&I was getting in. Is it a problem with these laterals? Are they all broken and cracked and allowing a ton of water to get in through that way? Or is it foundation drains? And we were leaning more towards the foundation drains at that time. We had plumbing card inspection records, but we ultimately wanted to figure out what was the leading contributor. And then as part of this second sort of study, we wanted to see, okay, if we go in thinking it's foundation drains, we also want to see what's this sort of effective zone of influence, or how far away from the foundation is that water. If we put a drop of water, within certain zone of that foundation, is it getting into the foundation drain and then into the sanitary sewer system? So this is a couple of sort of objectives, mini objectives that we had as part of this second part of that case study. Ultimately, we ended up doing a project video kind of summarizing this whole project. I've just snipped it down to a few seconds because I think it illustrates sort of the methodology that we used better than anything I could show in pictures or just describing it to you. So what we ultimately ended up doing was launched a lateral inspection camera. So this was done at multiple properties, again, twofold. Let's look at the condition of the laterals and make sure they're not all cracked and broken. If we're doing this during wet weather, we should see if they are, in bad condition, the water coming in. And then at the same time, we're also simulating the rainfall. So this is a downspout essentially, or two downspouts that were discharging in the same location. And we were pouring dyed water on the surface where those downspouts were already discharging. So at the same time that we have this lateral inspection camera in, we're doing this dye testing at the surface where we see these downspouts going in. And what we found is that it took only 10 minutes for that water that we're putting at the surface to get into the foundation drain and then into the lateral and into the sanitary sewer system. So when you think about, response, the response time in a sanitary sewer system, I mean, 10 minutes is really not that much. When you think about the response time at a downstream pumping station or a treatment plant, oftentimes that peak flow is maybe 4 to 6 hours later. So all of this flow is able to accumulate and go down and impact that sort of downstream infrastructure. So that was sort of the methodology. And again, that video probably shows a bit better than anything I could sort of describe as to what we did. And so this is just an example. So we would test, right at the foundation wall, we'll call it 0 meters from the foundation. And we would test and pour dyed water. So the first one on the left, we poured a red dye onto the right at the foundation wall, and then we would see it into the sanitary lateral and the main line within 10-20 minutes. And then we also did another test shortly after that with a green dye, again, at about 1.7 meters in this particular case from the foundation wall. And we saw it within, again, another 20 minutes or so. So we're just trying to see and trying to understand how far away from a particular foundation that even if you discharge a downspout and you're not concerned with maybe disconnecting the foundation drain, how far away from the foundation does that sort of zone of influence impact? So if you're looking at policies to disconnect downspouts and put them a certain distance away from the foundation, how do we help inform some of those policies? And we also, we did this for a number of different properties. We would have probably liked to have done more because, just to build our data set and build our sort of evidence and build out, the robustness of our analysis. But, it's very difficult to do this over multiple days, budget limitations and all that. So we have a few different results, and so it kind of helped us to inform, knowing that the majority of this flow is coming from foundation drains and not, defects within the laterals themselves, and then kind of try to make an assessment as to what that zone of influence on the ground is to come up with a recommendation as to how far away those downspouts should be discharged from the foundation. As part of this study, we also surveyed within that little part on the street, we surveyed 185 downspouts, and we found that majority of them actually discharge within 2 meters of the foundation. And that was sort of the zone of influence we came up with, is probably somewhere around 2 meters based on the testing that we had done. And so when you're looking at, the number of downspouts, even within less than half of meter, which we know for sure those are getting into the foundation drain, there's over 50 or, 25%, 30% of those downspouts were basically discharging right at the foundation wall. And so we know, almost with certainty that those are getting into the sanitary system. And it helped us sort of to quantify, to paint the picture for the city, and also quantify how much foundation drains were actually contributing to the overall problem in this particular location. So yeah, it was a pretty interesting study. Again, and we'll talk a bit about some of the challenges of doing wet weather work, but I thought it was a very interesting sort of case study to show today. So just a poll, I'd be curious to see if you do have a policy for downspout discharge distances. Do you have any sort of policy in terms of where you can discharge this, particularly if you do know that you have foundation drains that go to the sanitary sewer system, and typically that's municipalities that have development kind of prior to the mid 70s, late 70s. It was sort of standard practice in a lot of locations to connect foundation drains to the sanitary system. So it depends, right? Where you are, how old your municipality is, how old your system is, and also if you do have foundation drains connected to sanitary, and maybe it's only part of the municipality that's sort of that old, right? So okay, so I'll just quickly end this one. So we'll share the results. So it sounds like a good mix here. Some do have a policy around downspout discharge distances, and I know even within the GTA, we have the TRCA, CVC, some of the other conservation authorities have their own sort of policies or recommendations around downspout discharge distances from foundations, and trying to promote infiltration into the natural environment. So some municipalities may rely on some of that guidance as well, but an interesting sort of mixed bag of results there. Okay, and I'll pass it back to Alex to talk about some of the challenges with wet weather inspection.
Thanks, Matt. Okay, well, it all sounds very good, right? To do wet weather inspections. But you might come up with this question: why this does not happen a lot? Why there's not a lot of companies out there doing wet weather inspection? Well, I can speak from our experience. It's just simply it's very hard to do. There are a couple of challenges I can quickly talk about. First, these wet weathers, they're hard to anticipate. First, there's only a limited amount of kind of wet weather or significant wet weather that happen every year, depending on where you are, obviously. But you can only pray for this good weather, quote unquote good weather, and even when it comes to weather forecast, there's certain accuracy associated with that. So the good weather that you pray for a long time may not happen, or maybe the time it happens is not in favor of inspection if it happens in the middle of the night, or if it also comes with a thunderstorm, lightning, or big wind, these type of conditions. So it's not safe to work during this type of weather. So that limits the time window, or the window of opportunity that you can do wet weather inspection. And also it's very disruptive when it comes to the operations side. Ideally you would prioritize your field resources to do wet weather inspection when you anticipate there's going to be a event coming up very soon. But like I just mentioned, this rainfall events, sometimes they happen, sometimes they don't. If they don't happen, or if the time they happen, it's just not feasible to do inspection, then you will have to redirect the team to go back to other tasks. It creates a challenge to field operations, at least at the planning side. Like, what do we do when the rainfall happens? Like, do we have enough people? Do we have enough equipment? Do we have all the permits or the agreement from the municipalities to do all kinds of things during such a condition? So it all needs to be factored in. And also, you can imagine when it's raining quite a bit and when it's wet, it's not very comfortable. Staff are not very comfortable working during the rain. In summer it might not be as bad, but if it's spring or if it's late fall, you can get very cold if you're wet. And the equipment that we use, laptops or tablets, when they are wet, sometimes they just don't work. If you have water resistant equipment, they might work, but even things like a touch screen tablet, like we use them a lot to record data collect on field when the screen is wet. You put on your finger on this touch screen, they just don't work. And those are all challenges, add together, why it's tricky to do such wet weather inspection. And then last but not least, safety precautions. Like I mentioned, when it's wet, depending on the weather, you may not be able to do any field inspection. And especially when it's wet and dark, you want to make sure you have enough traffic control, you have good visibility, and you might need to have extra team to make sure staff are working on the field safely. So, well, because those good weathers are hard to anticipate most of the time. So is there an alternative to wet weather inspection? Well, for some of the field inspections, there is, and I'm going to go through some things that we can do to simulate wet weather conditions to a certain extent. The first one is dual drainage modeling and manhole flood test. So for those who are not familiar with this technique, basically, most of the sanitary manholes are on the road, and roads are designed to be a channel to convey stormwater. That's the major drainage for a stormwater system. So you would have a certain amount of depth of water when there's a major storm, and depending on the location of your sanitary manhole, if it's near the gutter or if it's in a low-lying area, those manholes get submerged, and you're gonna see a certain depth of water on top of the sanitary manhole lid. And manhole lid, they have typically one or two pickles. Mostly they have two pickles, and there's gaps between the frame and the cover, those gaps or allow water to enter the sanitary sewers. And you don't necessarily need to wait until a big rainfall happens to identify those manholes. Basically, what you can do is you can do a very detailed dual drainage modeling to identify those manholes are susceptible to flood. And then if you take a look at the picture on the right corner, we can do something called manhole flood test. Basically, you build a bulkhead around the manhole and start to build up the depths on top of the manhole lid, and we have a little device within the sanitary manhole underneath the manhole lid, obviously, and to measure the amount of water getting into the manhole at this location. So you basically develop site-specific capture curve. So the dual drainage model is going to tell you the flood depths on top of the manhole, and by having this capture curve, you can convert depths or head on top of the manhole to flow going to the sanitary manholes. And if you have a couple of locations, and you can anticipate this will be the amount of water if such storm happens, and calculate the amount of I9 going to sanitary manholes through the manhole lid. That's just one technique. And also on the left-hand side, we can do something called rainfall simulation dye test. What it is basically you pour a lot of water in the catchment or the drainage feature or around the drainage feature you want to test to simulate when it's dry. When it's raining or when it's soon after raining, your soil becomes saturated, and the hydraulic conductivity becomes high, and you pull enough water to simulate that condition, and then you do dye tests to eliminate the effect of the ground storage, for example, when it's dry. So you will see whether this downspout is going back to foundation drain and then goes to sanitary, or it's not connected, or it's far enough to be not connected. Also, there's one technique called storm sewer exfiltration test. This is a method, especially for those storm and sanitary sewers are sharing the same trench. So if you're interested to know whether there's some cross connection in that trench, you can basically block a section of the storm sewer and start inject water to that storm sewer and start to build up HGL to see plus some dye. And then you send the CCTV robot in the sanitary sewer to see if there's any dye water shows up in the sanitary sewer. If there is, that means there are certain connections, either it's direct connection or it's through exfiltration and then infiltration to the sanitary sewers. That's, like I said, that's usually happens when two systems are sharing one trench. And last one, inducement test. This is basically you inject water, for example, behind a manhole. You can do it during dry condition. You basically drill a small hole and start inject water at a steady pace and see if there's any water coming into the manhole. And this helps you to identify the manholes. And then you can basically do this to identify those manholes that are likely to leak during wet conditions and visit those manholes when it's raining, instead of just going through all the manholes or trying to go through all the manholes when it's raining. Obviously, you need a lot of resources to do that. But if you can identify these targeted manholes during dry conditions through this inducement test, and then visit those targeted manholes during wet conditions, that would be much, much more efficient. And then I'll pass back to Matt.
Awesome, thanks, Alex. So, I think, as Alex mentioned, there's quite a few challenges, but we have had quite a bit of success, and there's quite a bit of effectiveness in doing these inspections to find I&I, again, as it's happening, as the system sort of most impacted by wet weather flow. Dedicated forecasting and planning are key, certainly to our operations. Always looking at the weather and trying to come up with as much certainty as possible. And I know that technology is improving on that. So I think that will help us as we move forward to try and plan these types of activities going forward. And then, the sort of last little bit that Alex was talking about, sort of the simulated wet weather stuff. doing as much as we can to simulate or replicate the conditions that are happening during some of these storms. We're constantly trying to figure out ways to not be so reliant on Mother Nature, and I think that's something that we're going to continue pushing forward as we move forward to help us in these type of inspections. A few recommendations just for those out there, if you're kicking around ideas, flow monitoring is always a good first step when you want to sort of capture those elevated flows, those seasonal flows or rainfall derived I&I flows, and to help prioritize and think about where you want to do wet weather work. I think wet weather inspection should probably be added to any sort of regular I&I reduction program that you have, to supplement some of the more traditional inspections that you may want to do. If you have good flow data and you have certain assets that might be underwater during storm events, or you may suspect, or if you have foundation drains, or if you have other features that the pipes or maintenance holes that are maybe not in the best condition, and you want to see what's happening during these storms, and it's certainly something that should be part of the sort of overall I&I inspection and reduction program. And just lastly, on the foundation drains, I know it's a big problem across many jurisdictions. They definitely need to be considered when you're looking at I&I reduction studies. I know some municipalities are targeting them, disconnecting foundation drains, but even looking at, downspout discharge distances, if you can get a lot, maybe majority of that water from downspouts that's going from the roof right to that sort of zone of influence, if you can disconnect or remove a lot of that water, I think you'll see improvements in your systems. There are challenges associated with that, as I'm sure you're aware, trying to if you move a downspout, trying to make sure residents don't move it back, and so on and so forth. But there's certainly some ideas and some thoughts that we have around trying to make that a sort of more permanent solution. So always open to chatting about that if anybody's interested. So we'll end with a couple of polls. So just seeing if anybody's interested in a one-on-one session to explore, wet weather inspections in particular, or, just anything related to I&I. I mean, this is one sort of small aspect. Alex was talking about these other investigations, flow monitoring. This is a webinar we do usually once a quarter to some aspect of the work we're doing. But if you have anything you want to connect on, feel free to let us know, and happy to explore any problems or solutions that you may be looking for. Okay, just give that a couple more seconds. And then finally, how interested would you be in a pilot study to sort of prioritize wet weather inspections in your jurisdiction, or maybe you have an idea of where maybe foundation drains are going, or some low-lying maintenance holes. As Alex mentioned, the dual drainage aspect of trying to identify these locations on the road. We also have our last webinar, which is on our YouTube page and on our website. So you can, if you're interested, or if that kind of piqued your interest, feel free to go on our website, and that video should be available there. So you can check that out, and that's more of a simulated what would happen during some of these large storm events, and how do we target these things, and how do we sort of quantify how much is getting into the system. Okay. So yeah, we're just, as I mentioned, we have a YouTube channel. I think this is our, 6th or 7th webinar. So we have a lot of content. We're trying to keep putting stuff up just for people to maybe it'll resonate with them, and maybe they'll learn something. And if there's any questions, as I said, feel free to reach out. The full version, I think the video that I just showed maybe 45 seconds to a minute, but that full video from the project we did in City of Toronto is on YouTube. So feel free to go on and check that out as an additional resource. And with that, we have a few minutes. We can certainly stick around, but if there's any questions, feel free to throw them in the chat or put your hand up, and we can take you off mute. If you do have to run at 2, totally understand. And again, thank you for coming out. Thank you for your time. And then, feel free, between myself or Alex, feel free to reach out at any time. Always happy to chat and talk about I&I and everything related to system capacity. So thanks again. And yeah, it looks like we have one question, but again, if there are any questions or any, comments, even, always happy to discuss. So one of the questions, and maybe Alex, if you want to tackle this one, can inflow be targeted over infiltration?
Sure, maybe I can talk a little bit about this. It depends. Sometimes based on the flow monitoring data, depending on the I&I response, you could tell, this area has a lot of inflow, or, this area is also, the I&I is dominated by infiltration. Sometimes, especially when it comes to relatively large drainage area, it's all mixed up. So, the resolution you can get from flow monitoring or I&I response is not as good. But if you have a very good understanding of the drainage feature in this area, or for example, if all the downspouts, or a lot of the downspouts are connected to the sanitary, those are our inflow sources. And versus, if we just have bad condition manholes and pipes, those will be more infiltration type. But most of the time they're just mixed together, and you have to do different kinds of investigation to find it.
Yeah, I think that's a good point. A lot of the time, and I think where we see a lot of our problems, particularly basement flooding or bypassing, is that peak, right? And it's that inflow that people, or rainfall derived inflow and infiltration, and some of the more traditional techniques, even the smoke testing, dye testing, will hopefully find some of those things, catch basins and downspouts and things like that. But as Alex had shown, we went to some of those manholes and they were fine, and then we go during wet weather and they're gushing, and technically, from a technical standpoint, maybe that's more infiltration, but it's as a direct response to that rainfall event. So that sort of rapid infiltration too is something between that and these big inflow sources, I think, is something that we try to target a lot, because that's where we see most of the capacity issues happening. I mean, there are certainly some jurisdictions, some municipalities that have these huge seasonal increases in flows, in the springtime, for example, in Southern Ontario. And that's definitely something that takes up a lot of capacity, just these consistent high flows due to groundwater getting in. So I think the solution and the target there is probably a little bit different, but for the most part, trimming that peak has such a large impact when it comes to your sort of overall I&I reduction program. How far of a distance do you think dewatering studies should consider for foundation drainage? That's an interesting one. I don't know, Alex, do you want to tackle that one? I think it depends, right? Like, I know I'm thinking like downtown Toronto, where they're digging 50, 100 feet under the ground, is a little different than a residential foundation drain, right? But,
yeah, in some areas, it's easier to do than other areas, and in general, tackling foundation drain is a harder task compared to fixing other ionized sources. Because it's mostly on the private side, and convincing homeowners to disconnect foundation drain, putting sump pumps, and just a lot of education. And when it comes to the cost of doing such a remediation compared to others, like downspout disconnection, or even just fixing manhole, like a spot repair, or sealing manholes, the cost on the foundation side is much higher. So really depends on the situation, how big of the problem is caused by the foundation, or compared to the investment. This is the return on investment question, like how much of effect does it bring to by doing such fix.
Yeah, and I think the study that we showed, and again, we have sort of limited data, but we were testing over a meter and a half, 2 meters from the foundation wall, and the flow was still getting back to the foundation drain in some instances. And the other thing, this is, I think most of the homes in this area were built in the 50s and 60s, and a lot of settled, and the grading is, obviously a factor. For the one that we did find, it was 1.7 meters. It was still getting back to the foundation drain, and I think there was about a 6% slope away from the foundation. So, yeah, I don't know. When I think ultimately our recommendation from that report was at least 2 meters away from the foundation is a good idea. I think it's in line with TRCA has their recommendation. I think it's 2 or maybe even 3 meters away. So when it specifically, anyways, to the residential stuff, I think probably at least 2 would be a good starting point. Okay. I don't see any more questions, so again, I'll stick around for the next couple minutes, but if there are any more questions, feel free to throw them in the Q&A or put your hand up and we can take you off of mute. But yeah, I think feel free to stick around. All right, well, I don't see any questions coming up, so we'll end the webinar now. And like I said, thanks everybody for coming out, and keep an eye out for future webinars that we're doing. And as always, feel free to reach out if you want to chat. Always happy to connect with everybody out there. So yeah, have a great day, and happy wet weather inspections.